Hello and welcome to the Equilibrium Lab. So for this lab, we'll be using many chemicals and looking at the equilibrium constant involved in the chemical reaction of the iodine clock. Now, as you see, we have 5 complete chemicals that we'll be using, and we'll be using them in different concentrations and different temperatures to be able to graph their different rate constants and figure out both the rate constants and the activation energy. We'll be doing that by mixing them in these test tubes here. So let's talk about what those chemicals are. We have ammonium peroxide disulfate, 0.1 molar, ammonium sulfate, also 0.1 molar. We have potassium chloride and potassium iodide, both 0.2 molar, as you see here. And finally, sodium peroxide disulfate there, and 0.005 molar. So these are the reactants we'll be using. We'll be using volumetric pipettes to transfer the liquids from those bottles into our test tubes. And we will also prepare a hot water and cold water bath, as you see here. And that's to look at the effect of temperature on those reaction rates. So it's very important to not let any of these chemicals touch each other until they're ready to be mixed. Otherwise, it'll set off our calculations. Because of that, you'll see I have different pipettes for each chemical. So we're going to set up 3 different experiments. For the first one, we're going to use about 1 milliliter of potassium iodide, as you see here. All right. To that test tube, we're going to add 1 milliliter of potassium chloride. Notice how I'm using very, very specific and exact amounts because that is very important for this lab. Now, we also need to add 1 milliliter of sodium peroxide disulfate. And then because we're going to be using a color change to indicate when our reactions have gone to equilibrium, we're going to add to this test tube a couple drops of starch solution. Now, starch solution doesn't actually take place in the main reaction, but it is a color indicator when the reaction has reached equilibrium here. So we'll go ahead and get the starch solution ready. And just a few drops of starch solution is all we will need to go ahead and get that reaction going, and go ahead and get that reaction to its color indicator. All right, so for the first test tube, we're done. For test tube 1B, we're going to just have 2 milliliters of ammonium peroxide disulfate. So that test tube will just have those 2 milliliters. So if you're keeping track, you'll notice that when I mix my test tube 1A and 1B, we will have a total of about 5 milliliters. Okay, so we're going to go ahead and prepare all of the 6 test tubes first. Now, for test tube 2A, we're going to start with 2 milliliters of potassium iodide. We're going to add to that 1 milliliter of sodium peroxide disulfate. And then for test tube 2B, we're going to go ahead and put in 1 or 2 milliliters of ammonium peroxide disulfate. All right, and then for experiment 3, the first test tube, or test tube 3A, is going to start off with 2 milliliters of potassium iodide. To that, we're going to add about 1 milliliter of sodium thiosulfate. And we're going to add in our couple drops of starch. We'll go ahead and add it to test tube 2A while we're at it. All right, so all of the A's of the experiments are done. Let's go ahead and get our test tube 3B done. So that requires 1 milliliter of ammonium peroxydisulfate. Along with a milliliter of ammonium sulfate. Okay, so when we go and do this experiment, we're going to mix the test tubes 1A with 1B, 2A with 2B, and so on, and we're going to time it. So here's the mixing of test tube 1A and 1B together. We're going to go ahead and pour it in 1B into 1A, and then I'm going to kind of mix back and forth for a little bit. And I'm going to go ahead and start my timer, and we're going to see how long it takes for this reaction to reach equilibrium. And I'll know it's reached equilibrium when that clear color becomes a kind of dark bluish purplish color. That means that it's reached equilibrium and the starch solution has reacted. All right, several minutes later, you can see that nice purplish hue. So we're going to just do that same thing for experiments 2 and 3 until we reach that purplish hue for each one. And we're going to record how long, how many seconds it takes for each one to do that. So go ahead and start doing that for experiment 2. So we'll mix 2A and 2B together. And start that timer. And we'll wait until it reaches the hue, and we'll do that same thing for experiment 3A and 3B, or test tubes 3A and 3B. All right. Okay, so you can look on your data sheet to find the times for all 3 of those trials. Now we're going to prepare experiment 2 more times, or 3 more times, and we're going to use the 3 different trials there to look at the effect of temperature. So you can see we have one water bath that is fairly cold, about 4 degrees Celsius. We're going to have one water bath that is a few degrees above room temperature. So you can see that is about 53 degrees Celsius. And then one water bath that's just about 10 degrees below room temperature. That's about 14 degrees Celsius. And we're going to put those test tubes in those water baths for about 5 minutes to let the solutions acclimate before we run the experiment. So now we're going to go ahead and mix those test tubes together and then do the same thing. We're going to measure how long it takes for the reaction to reach equilibrium. So we'll look for that purplish color once again. So that's for the 10 below room temperature one. We're going to go ahead and mix that. and then let the reaction go. We're going to time how long it takes to reach completion there. And then same thing for the one that is slightly above room temperature. Okay, we'll go ahead and start the timer for that one. All right, so now we'll just have to wait to see how long each one takes to reach equilibrium and record that, and that will help us find the overall reaction rates. So you see there, we're still waiting. The one on the left, the heated one, you can see is starting to turn purple. There we go. So I'll go ahead and stop my timer right now and record the time it took for that first one to reach equilibrium. As you probably suspected, the ones at higher temperature take a less amount of time, or they're quicker to reach equilibrium. So the one above room temperature was the first to reach equilibrium, as you see there. We'll just have to wait for the other two to catch up. Now, I've recorded the data for all of those trials in the data sheet as well. And that is all. Thanks for watching.